Hi everybody. I wanted to put this video together pretty much because I want to really expand on how much I like this 3D printer. Okay, the biggest reason I think I've been motivated to make this video, and I know I'm behind on all my aviation videos, and I apologize for that, but the biggest drive I have in making this video is I see all kinds of videos on YouTube's about people modifying this printer, this 3D printer. I see where they're talking about just all kinds of things that they're changing on it, and I just want to share some of my success with it. I've had the printer about 6 months. I have 1,255 hours of print time on it. I have 13,700 and some feet of filament I ran through it. Okay, over 2 miles of filament, 13,000 feet. So coming up on 3 miles. So when you start thinking about it, now right now my spool's missing because I put this in a box to keep the heat up a little bit. But a couple of things I want to talk about is if you build this straight out of the box as is, you don't need to modify a thing. Okay, I see people that are measuring stuff and people that are talking about different parts being weak. This printer has printed things from this head to this test fan that I'm working on, this arm, which actually came out bad because of all the faces I had, so this actually would look a lot better, but if you look, it printed virtually perfect. Okay, I printed the exhaust pipes for one of my big half-scale aircraft. Now, you know, it's an electric aircraft, so these are fake exhaust pipes, of course, but I printed these, okay, with this printer right here. This jack stand I printed, so if you got your aircraft and you're going to put it on a scale jack stand, this is the one I designed. I've designed quite a few structural parts for my aircraft that's worked really good. You just got to make sure you use the right material. I 3D printed this guy in one print, which I think is just really, really awesome. This guy I printed in one print. Okay, these hands I printed. So I guess my point here is that for around $699 US dollars, you get this kit, you assemble it. I think for another $200 you can buy the kit completely assembled. But this Prusa i3 Mark II that I haven't had to change, well, I haven't had to modify anything. Now, there is a little brass drive gear that helps run the filament into it. I did wear that out. And I asked Prusa about it, and they said, look, if you're going to run 2 miles of filament through it, it could wear it out. Now, I'll be honest, part of that I think was my fault because I use a lot of carbon fiber nylon or nylon impregnated with carbon fiber. And what I did was I actually had some dirt get down into my hot end nozzle. And when it jammed and stopped, that little gear was turning against one of the hardest materials you can print with this, which was a nylon embedded carbon fiber. And I think that carbon fiber actually helped wear out that little gear. So for like $8, I think it was, or $7, I got the new gear, put it in there, and it's been working flawlessly. But that didn't fail until I had over 10,000 feet. And right now, I keep looking at my notes here, I have 13,000 feet I ran through this. So I don't know why so many people want to take something that's perfect and play around with it. Okay, I have not had to do a thing to this printer. I've only had to recalibrate once or twice. There is a thin like plastic material on here that I damaged once, my fault. You basically put this in a deep freeze it. You can peel it off. I use a little bit of acetone to remove the glue, put the new one on, and I'm good. But if I had not have screwed up, this is 100% stock. Okay? So I don't know what all these videos are out there of people needing to modify perfection. Okay, in my opinion, and I've talked to a lot of other people that have 3D printers that are trying to print higher temperature stuff like the nylons with the carbon fiber in it and stuff, and most of them say they're jealous of this 3D printer because I'm able to print so many cool things with it. I mean, I'm actually going to be using it because I'm developing a really large fan. Now, just so you know, these blades are being 3D printed so I can pull molds from them so I can actually make these blades out of carbon fiber. And these two end rings will be T6 aluminum that I'll turn on my lathe. But for a prototype, I've printed this. Okay. Now, what's really, really cool here, if I can take this apart right now because it snapped together. Awesome. So, basically what I've got here is all of my blades. So I 3D print this blade. Now this particular blade I 3D printed flat. And I didn't need to put any structure to hold anything up. The printer actually did it. Now, you can look on the back here and see a little waviness. Okay, that's because the angle got so close to being flat. But I'm going to prime this, sand this down, and use this to pull a mold from. So what's really, really awesome about this printer is this basically printed flat like this. I hope you can see that. Okay, this printed as one piece. This has a pretty big bed. Okay, it's about 9.8 inches by 9.8 by 8.3 by 8 inches tall. So I think that's 250 millimeter by 210 millimeter by 200 millimeter tall. So I just wanted to do this video because I keep seeing all this stuff on YouTube where people are talking about these are being weak and how they have to measure things. I got to be honest. If you just make everything as square as you can get it and pop everything together, I had zero problems with this needing to be down to the 64th of an inch anywhere. Okay? I'm trying to think on maintenance with it. I might put a couple of drops of silicone spray lubricant on it. And I've just run the guts out of it. I mean, many times it will run, I think to print this took 30 hours. And I just let it run for 30 hours. I've got over 30 hours in printing all these parts, not in one print. I mean, normally when I print these parts, I will stagger them on the bed like this. So I can get 4 at a time. Okay, and I'll print 4 blades at a time. I want to get all 14 blades printed just to kind of understand how it's going to work in the unit I'm designing. But none of these will be flight worthy. This I might print out of the carbon impregnated, the nylon that's carbon impregnated, and just see how much I can spin it up and blow it up. So if I do that, I'll try to do it in as slow motion as I can. But this I think I'm actually going to put on my test rig and spin up and see what happens to it. These definitely won't work. But really, that's all I want to do with this video is talk about my success with this 3D printer. It has just been phenomenal. I've not had a single issue. As far as support, they kind of had a little bump in the road when they were moving from one factory to another factory and didn't respond to emails for like 3 or 4 days. But right now they respond to emails. They have a 24-hour online chat, which is just ginormously awesome, because if I ever got a question about something, I can just ask them through a chat. And almost all the problems I had was problems I created myself. Okay, I just wasn't doing it right. I didn't have the temperature set right for the extruder nozzle. Okay, so as I said in one of my other videos, 3D printing takes a little bit of understanding about how all this stuff works. But I got to be honest, this 3D printer by Prusa is just an incredible workhorse. Hopefully it doesn't blow up now next week after I made this video. But there's really, it's such an open architecture. You know, if one of the steppers went bad, I just got to replace the stepper. I read online where somebody said the stepper shouldn't get hot, and I actually went to the stepper manufacturer's website, and they can get rather hot. They can get up to 50°C. They shouldn't go past 60°C. So it was really interesting, some of the stuff I started to research on the back side of things. But that's pretty much it. The only mistake, the only thing that really bothers me about this whole thing is I didn't buy 2 of these. Because many times I'll have this printing for 20 hours doing something when I need to be experimenting on another thing. And it just really bothers me I didn't buy 2 of these. And right now funds are tight. But my next big goal is to buy a second Prusa. Because I want one to always, when I'm doing my prototyping stuff like these blades where they take, I think Actually, I think I can get 6 at a time on that bed. I think when I print 6 at a time, it takes 26 hours to print. And, you know, that just takes away from everything else I'm trying to do. So, hope this video is informative to you. If you really want a 3D printer that is going to be an absolute workhorse, is very, very accurate. Okay, I don't know what all these people on the internet are talking about, all these adjustments and all this beefing up they're doing to get good prints. This does phenomenal prints. I don't know, you know, when you start looking at stuff like this and you look at some of these heads I've done, I don't know what they're expecting a 3D printer to do. It just doesn't make sense to me. So the pros is the size of the heat bed. Some people say it prints slow. I print stuff very, very fine, so it takes a lot longer. If I print it coarsely or fast, it could print as fast as most other printers. Okay, I want to have a little bit. If you look at some of the structural parts I made, you can see the layers in them because I printed them quite quickly. Okay, but if you look at some of, especially these fan blades I made, I printed these a little bit more fine so that it didn't have as many layers visible in it. So I don't have any cons in this 3D printer. There's nothing about it I don't like. Just the fact I don't have 2 of them. So, you know, I'm going to really have to figure out how to get the funds to get my second Prusa. So, hope you love this video. I hope it's informative to you. And, of course, on all my aviation and sales stuff, keep the emails coming to me. And if you have any questions about this 3D printer, just email me. Thanks a lot, everybody. Have a wonderful day.